In this homework video guide, we're given a graph of y equals to f of x, and we have to determine whether each of the following statements is true or false. All right, so for question number one, if I take a look at this statement here, the limit as x approaches -2, and we're approaching it from the left-hand side, right? So this is actually a left-hand limit, and we're approaching a -2. So there's -2, and if I approach -2 from the left-hand side, the height that I approach is actually going to be +2. So the left-hand limit is equal to 2 here. And then, because of this plus sign, I'm looking at a right-hand limit. All right, so that +2 indicates that we're looking at a right-hand limit. So if I go back to my graph now, if I approach -2 from the right-hand side, the height that I approach is also going to be +2. So the left-hand limit equals to the right-hand limit, so this statement is going to be true. Okay, let's take a look at question number 2 now. So for question number 2, the limit of f of x is as x approaches -2. All right, so if I approach -2, the overall limit is going to be +2 because the left-hand limit and the right-hand limit are both 2. And then, let me just erase this. Then I need to evaluate f of -2. So when you're at -2, what's the height that we have? That's going to be +2, so that equals to 2. So 2 equals to 2, so this is going to be true. Okay, and then for the third question here, I have this statement right here, that prime, and there's also this minus sign here. So this means the left-hand derivative, right? So when I look at -2, because that's the number approaching from the left-hand side, this statement is asking what is the slope? What is the slope of the slope when we approach -2 from the left-hand side? So basically, if this is -2, if I approach this from the left-hand side, I want to know the slope of this line. So what's the slope of that green line? Well, it's basically simply a rise over run. So up 2, a rise of 2, and a run of 2. So 2 divided by 2 will be +1. So the slope of that green line is going to be +1. Okay, if I take a look at this statement over here, I see that plus sign. So this time this means the right-hand derivative. So when I'm approaching a -2 from the right-hand side, basically I want to know what is the slope of this linear line. All right, so it's a constant linear line. So if I calculate the slope of that, that's going to be a rise of 2 and a run of 1. So that slope is going to be -2, right? So that slope is -2. So since the slopes are not the same, this is a false statement. And that's all we're doing for this particular question here. We're just looking at the statements and we're evaluating both sides and we're coming up with true or false statements. Okay, let's move on to the next set of questions here. So questions 4, 5, and 6. For question number 4 here, there's this limit with that prime sign, and I'm approaching the left-hand side of -1. So here is -1 right there. So I want to know the left-hand derivative. All right, so that means what is the slope of this line that's on the left-hand side of -1? And that slope of that line is a rise of 2 and a run of 1. So that slope is going to be -2. And then if I take a look at this statement right here with that limit sign with that prime sign, that means the right-hand derivative because there's a plus sign there. So this is the right-hand derivative. All right, so if I look at the right-hand side of -1, what's the slope of that green line? Well, the slope of that green line is also going to be -2. So since the slope on the left-hand side of -1 and the slope on the right-hand side of -1, they're both equal to -2, so this is a true statement. Okay, let's move on to question number 5. So question number 5 is asking, what is the limit as x approaches 0? Does it exist? Okay, so let me just erase this. Okay, so here's 0. And if I approach a 0 from the left-hand side, the left-hand limit is -2. If I approach it from the right-hand side, the height that I approach is also -2. So does the limit exist? The limit does exist because the left-hand limit equals to the right-hand limit. They're both approaching a height of -2, so this is a true statement. Okay, and then let's move on to the very last question here, the limit as x approaches 0. Well, the limit as x approaches 0, we know that's going to be -2 based on question number 5, and is that equal to f of 0? Well, f of 0, that's going to be false because f of 0 is equal to -1. So when x equals to 0, the only value that's defined there is -1, so this is going to be false. Okay, let's move on to the next set of questions here. Okay, let's take a look at question number 7 here. Now we have some derivative statements here. So this right here is like the definition of the derivative here. And basically this is basically asking, I see a 0 there, and then this whole thing means the definition of the derivative. So basically what this is asking is, can you find the slope, because that's the definition of the derivative, at x equals to 0. Okay, so go to 0 here, and can you find the slope at x equals to 0? And if I go to 0 there, I mean there's pretty much a hole, right? There's a hole at x equals to 0, so the answer is no. It's not differentiable, right? So not differentiable because of the hole, and this statement would be false. All right, so it does not exist, right? It's not differentiable, right? Not differentiable means you can't find the slope, and that's because there's a hole at that particular point, and you can't find the slope at a hole, right? So that's it. Okay, moving on to question 8. F of 1 is not defined. Okay, so F of 1 is right there. There's a hole there, so true, it's not defined. There's a hole there, so nothing exists. And then over here, I have the definition of the derivative gain, and the value that we're looking at is going to be positive 1, right? So does this mean, basically this means, can you find the slope? That's what the definition of derivative means, at x equals to 1. Okay, so when we're at 1, which is like right here, so here's 1 right there. The question is, can you find the slope when x equals to 1? And that answer is no, you cannot, because there's a hole. So it's basically the same reason as this one here. It's not differentiable. So the reason is it's not differentiable, so you can't find the slope at that particular point. So this statement is going to be false, right? It does not exist. It's not differentiable, so it has to be false. Okay, let's move on to the next set of questions here. Question number 10, 11, and 12. So for question number 10, we have this notation again. So this is the definition of the derivative, right? And basically this means, can you find the slope when x equals to 1? Sorry, it says it does not exist, right? So it's saying the slope at x equals to 1 does not exist. All right, so we kind of just did this question here. So there's 1, and for sure you can't find the slope at a hole, right? So definitely the slope does not exist. So this statement is true. It matches the statement does not exist. Great. Let's move on to letter number 11 here. So I have the limit as x approaches 1 from the left. So here is 1. If I approach 1 from the left-hand side, the height that I approach is going to be 0. And if I approach 1 from the right-hand side, I also reach a height of 0. So the left-hand limit equals to the right-hand limit. So for question number 11, this is going to be true, right? And that's because the left-hand limit equals to the right-hand limit. Perfect. Okay, let's move on to the next one here. And for question number 12, the limit of f of x as x approaches 2 does not exist. Is that true or false? That's probably going to be true, because here is 2 right there, and if I approach 2 from the left-hand side, the left-hand limit, so the left-hand limit, the height that I approach is actually positive 2, and is that equal to the right-hand limit? Well, the answer is no, because the right-hand side, I reach a height of positive 1, right? So since the left-hand limit does not equal to the right-hand limit, the limit does not exist, so this statement is going to be true. Okay, let's move on to the next set here. So question number 13, 14, and 15. So question number 13, if I look at the statement here, the limit of f of x as x approaches negative 2. All right, so that's going to be equal to, that does not equal to f of 2. Okay, so what's f of 2 here? So if I go back to here, f of 2 is actually going to be this height. So that's going to be equal to positive 2. And what's the limit as x approaches 2 from the left-hand side? All right, so here's 2. If I approach 2 from the left-hand side, the left-hand limit is also going to be 2. All right, so it turns out that the left-hand limit actually equals to f of 2, right? So they're both equal, so basically this statement has to be false, right? It's saying that they're not equal, but they are equal, so this has to be false, right? So question number 13 is going to be false. Okay, let's take a look at question number 14 here. So for question number 14, I see this definition of the derivative symbol again. So that is saying, does the slope exist when x equals to 3? So when x equals to 3, so where is 3? 3 is right here. Are you able to find the slope? And the answer is yes. There's a tangent line, right? So I'll just say yes. All right, it's differentiable there, and you can draw a tangent line. So anytime you can draw a tangent line, then the slope does exist. Okay, and then for question number 15, basically we have another limit statement. The limit as x approaches 4 equals to f of 4. Okay, so here's 4. And if I go straight down, it turns out that the left-hand limit and the right-hand limit both reach a height of 4. And then what is f of 4? Well, f of 4 is just the height, which is going to be, whoops, sorry. Let me redo that again. I just kind of botched that here. So as x approaches 4, the height that we have is -2, right? So this limit's going to be -2. And it turns out that f of 4 is also going to be -2. So this statement is true. Okay, so just draw the left-hand limit there, the right-hand limit. They both approach a height of -2. And this point right here is also going to be, that also has a height of -2, so that statement is definitely true. Okay, so we move on to question number 16 now. 16. All right, so we have the definition of the derivative again, and that's saying that the slope when x equals to 4 is equal to -2. Okay, so once again, what does this definition of derivative really mean? It means when x equals to 4, the slope equals to -2. So is that true or false? Okay, well here's 4. If I go straight down, it turns out that the slope is actually going to be 0 because there's a horizontal tangent line, right? So basically this statement is going to be false, right? Because this statement right here basically means that the slope when x equals to 4 is 0, and 0 does not equal to -2. So this statement is going to be false. Okay. All right, let's go to question number 17. The limit of f of x as x approaches c exists at every c in the interval 2, 6. Okay, so where is this interval 2, 6? Well, here is 2, and there is 6, right? So if I look at the graph in that interval, this is my graph. Now, basically this c means these are x values. So we have many x values in this interval, right? So if I just draw above here, I mean, these are all the x values that are in that interval, right? So we are calling that c, right? So because that function is continuous, it's differentiable, so is it possible to find the limit everywhere in that yellow region, in that interval from 2 to 6? The answer is yes, because we don't include the hole and we don't include this endpoint. It turns out that, yeah, we are continuous at every single interval there, so it should be true. All right, so you can definitely find the limit anywhere in that interval. Okay, let's move on to a few more here. Question 18 here. Question 18 is very similar to question number 17, so we're still looking at the interval 2 to 6. So here's the interval 2, and here's the interval 6, so we're pretty much looking at this interval. And if I look at the graph in that interval, I mean, this is the graph that does exist in that interval, right? And we're not including the endpoints, right? We don't include those, right? So is it possible to find the slope anywhere in that interval? And my answer is going to be yes, because you know, I can draw tangent lines everywhere, right? So these are all the tangent lines that I can draw in that interval. So yes, I can definitely find the slope at any given x value in the interval, so this is going to be true. Okay, let's move on to number 19 now. 19, 20, and 21. So these are some very quick ones here. So what does this notation means? It means when x equals to 3, -3, the slope is equal to 1. So is that true or false? When x equals to -3, here's -3 right here, the slope is equal to -1. Well, what's this slope right here? Or sorry, let me kind of rephrase that again. I feel like I mispronounced that. So basically this means when x equals to -3, which is right here, the slope is equal to 1. All right, so if I go straight up, is this slope equal to +1? and that's true because the rise is 2 and the run is 2, so the slope of that linear line is indeed 1, so this is going to be true. Okay. What about f of -1? Alright, so what's the slope when x equals to -1? Well, here is -1 right here. And basically, are we saying, is this slope equal to 0? And the answer is no. That slope is not horizontal. It's another linear line, so this slope is actually a rise of 2 and a run of 1. So this slope is actually equal to -2, right? So it's not equal to 0, it's equal to -2. So this is going to be false. All right, the slope is not 0, it's -2. And what about this one here when x equals to 4? So here is 4. If I go straight down, is the slope equal to 0? The answer is true because there's a horizontal tangent line there. Okay, let's move on to the very last question here. Here's a weird graph here. So we're just looking at the slopes at various points. So when x equals to 3, okay, so here is 3 right here. If I go straight down, I don't know what that slope is right away, but I know it's negative. And if I had to approximate that slope, let's just say that slope is -1. So the slope when x is 3 is going to be -1. And then let's just take a look at this statement here when we're at 4, which this is 4. If I go straight down, the slope of that is going to be 0, right? So definitely 0 is greater than -1. And then let's take a look at the slope. Let me get a different color here. Let's look at the slope when x equals to 5. So here's 5. If I go straight down, this slope right here is definitely going to be positive. Maybe that slope is a value of 1, so let's put a 1 there. And 1 is definitely greater than 0. And 0 is greater than -1. And then what about 5.5? 5.5 is like, actually, let me get an orange marker here. So let's look at 5.5. 5.5 is about there. And this slope right here is even steeper, right? So maybe that slope has a value of 3. So if I look at the inequalities here, all these inequalities actually line up. 3 is greater than 1. 1 is greater than 0. And 0 is greater than 1. So this statement has to be true. Okay, so that concludes this homework video guide for this particular assignment.